So now that we've got a 360 representation of our environment, there's this handy little light called environment light. I'm going to hook that up to the spherical map, and the environment light expects a spherical texture to change any object's specular color that shares the same scene with that light. So let's quickly go back to our 3D scene up here and close those panels because I don't want to see the downstream. I just want to see our master set up here. And I'm going to create a card that lines up with the front of that house to make sure that that's what will be receiving the reflections. I'm going to scale it up. Hit F to center the viewport on the object and orbit around it. And just tweak the lineup a little bit. And scale it so it kind of sort of sits where the reflections are going to go. Probably just about here. So I'm going to grab this and combine it with my environment light down here, again using a scene node. And because we've got one, I'm stealing the render setup rather than creating it from scratch. This time, again, I don't need the Z-blend mode, so I'm switching it off. And I'm also going to switch off those expression links for now. Okay, so we've got this little 3D scene here now. Let's pull that further down to give ourselves more space. Which is not going to output much at this stage, because as I said, the environment light, if you check the little help on it, it says that it requires a spherical mapped image to produce a light specular color. Well, it probably produces specular color, but the object doesn't have any specular properties, so we've got to give it one. So we'll just go to the shader tab in the 3D menu and create a simple specular shader and plug that in, and now we're getting results. And I'm just going to crank up the white to 1 and decrease the shininess to basically make this like a fully reflective surface. We can always come back and tweak the look of the whole reflection later in the on shader level or by color correction afterwards. So now that we've got this, we can combine this into our main comp. So again, I'm going to select A input first, and then my B input, oops, not caps lock, no, shift. A, B, hit M for your merge, and you're connected. It looks so photoreal, doesn't it? Mm. So back into the card, we'll adjust it a little bit. You can see, you see the 3D overlay of the axis actually on top of your 2D buffer, which is nice, so you don't have to switch back and forth all the time. So we've got that in place just about right now. And I'll just pull a quick luma key to grab all this stuff. Again, this is more proving the concept. I'm not going to spend a huge amount of time on getting it all nice. There is a bit of a delay here with that screen capture stuff. Okay, I'll just check the channels, green channel. Let's just crunch the hell out of the green channel to create something quick. It's perfect, it's beautiful. Mm. That's what you want.
Oh, good.
So if you need a better mat, just ask Tahl. He'll be happy to do stuff. Again, make sure that your white clamp is checked, because if you look at the values down here, by adjusting the white point down to 0.15, we're now in hugely high hot values in our alpha channel, or in the green channel, which is going to be serving as our alpha channel. So white clamp on, and we're nice and flat here now. Obviously, don't do this if you grade RGB, but yeah. So let's say that's great for our holdout, and this time I'm not going to use the stencil, I'm going to use the mask operator, and I'm just going to select my A input, select my B input, once again hitting M, create my merge node, but this time I'm going to set it to mask. Right, this doesn't look right, and Once this is set to mask or stencil or in and out or any operation that actually assumes a single channel as a component of your RGB math, in this case, the mask input is using a single channel from your A input. It only cares what's in the alpha channel. It doesn't care about red, green, blue. As you can see, I can turn those off and nothing changes. Because the math behind it is really stencil out the B input with whatever's in the alpha channel in the A input. And because I crunched the green channel in the grade node here to use as an alpha, I can just switch this to green rather than shuffling green into alpha and then going into that. That's just, unnecessary. So now we've created a basic setup to replace the sky in here. And the cool thing is that we've come in 2D. Well, actually here, we've come in 2D with the sky. We've pushed it through the 3D system. We're rendering it into 2D. Here, we're pushing the 2D back into a 3D system. We're rendering it back out into a 2D, and that's in our comp. So everything is live. And that's one of the huge advantages of having a 3D system inside of Compositor, because you can keep things live. If you had to do this in Maya, then it just wouldn't quite work, because if you then decide you want to rotate the sky, you'd have to re-render your Maya stuff. And you can see the reflection actually is rotating the wrong way. It should really rotate the opposite way than the background is rotating. And that's because the environment light, by default, wants to mirror the environment map. So we're going to switch that off and rotate the sky again. And now we should be seeing, it's very subtle. Let's try bigger increments here. Yeah, you can see that it's the very overcast part of the sky on the other side. Just keep rotating, but you can see the reflection change there. So with this setup, it's nice and scalable. The cameras are all cloned. We've got our projection setup here, which is using user value rather than killing the animation and losing track of which was your reference frame. Oh, actually, I skipped something here. I prepared earlier trick didn't quite work here. Yeah. So let's kill that and come back to a little trick I like using. I know TCL is not quite the official script language anymore, but for some things it's still better and quicker and more intuitive. You can use both Python and TCL and actually HTML as well in your label to do whatever you need to do. In this case, let's say I can't remember what my initial projection camera for my Bezier up here to hold out those cranes, what that was like. So what I like doing is, in square brackets, refer to the value that I want to see in the DAG. So I'll just type value, followed by the name of the knob that I created, which was ref frame. So now I can see it in here, and if I change it to anything else, like 100, I would have known much earlier what I screwed up earlier, because it's right in my face. Yeah, you're always smarter afterwards, aren't you? So you can write whatever garbage in here and then make it all nice and fancy with expressions and tying scripts into it and whatever. This can actually be quite a complex script, and in fact you could, in theory, reference an external script file and do whatever you want to do with it. If you do any sort of complex scripting in here, be aware that this is going to be updated very, very often. So don't do stuff in here like reformatting your hard disk or copying files or downloading Google or something, because you'll be doing it a lot without you even realizing. So cool. Let's have a look at the finished QuickTime. We've got the sky, we've got the cranes removed, we've got a restored edge on the Gherkin building here, and we also have the reflection of the sky that is replaced. So now that we're panning up into that hotspot, you'd probably expect some sort of flare.
Yeah, that's what the shot's missing there. It needs a lens flare.
I mean, that's the real reason we picked this shot, because we're really desperate for a lens flare. I mean, who's not? Come on.
Yeah, exactly.
Everybody pretends to hate it, but really. You're all alone at home looking in the mirror, and like right next to that poster of lens flares and, you know, those 80s after effects.
Every shot needs a lens flare.
So, one more thing that I would like to show. Obviously, you can use cards and projections and complex stuff and texturing and whatever. But what if you actually just need that 2D track, that 2D information from an arbitrary point in 3D to plug into something like the source for a lens flare? You can't put a lens flare on a card, right? Because it's dynamic. It changes with position, and depending on the center of the image, the lens flare does different things. So you really just want that bloody 2D data. You don't want to push pixels through, or want to get pixels out of the 3D renderer. So what you can do, create your axis and position that where you want to extract some 2D information from. So actually I want to line it up to my hotspot in the sky, which is there. Jeez. So I'll move it over here. Since this is really big, I don't really have to be that perfectly accurate with it, because the parallax is pretty much neglectable at this point. But anyway, let's pretend this is great. So looking through the 3D camera, render camera, lock, zoom out a little bit. So now we've got this axis that lives up there, but it's still a 3D position. And then there is one of my favorite nodes in Nuke, which is the reconcile 3D node, which is essentially like a tracker, except you don't 2D track a feature. You use an axis and a camera, and it will project that 3D position into your image space and produce a tracker for you. So one last time, well, almost one last time, we'll copy that render camera and plug it in here. And I'm going to create a constant node to just drive what output format, output resolution we want in this. Making sure that the format in the constant is the same exact format as our comp is in. Like you can see that down here in the lower right corner. We're comping in HD. This is the constant node itself is referring to the root format, which again is set to HD. So that's all good. This is our little setup. And now the fun bit, we hit create keyframes and watch. And yay, here goes our 2D tracker, which would be very hard to 2D track because it's not even in frame. So there. So now we've got a 2D track of the position of the sun without any hassle of offset tracking or exporting Chen files or anything out of Maya or whatever. And it gives us a nice keyframe animation in XY output. In fact, it can resolve and reconcile 3D hierarchies too if you need that. But let's just focus on the 2D output here and create that awesome, awesome node called Flare. There it is. Right. It's beautiful. Okay, and actually I'm going to bring that up as a floating panel, because you can bring that up as in whatever way you want to. So right, we've got the animation in the reconcile 3D node, and we've got the position here, so we'll just control or command drag that over to create an expression link, and that is displayed as a green arrow in Nuke. And for Shake users, yes, it's the inverse. Nuke tells you, if you look at this little arrow, Nuke tells you which node is being controlled. So it points from the master node to whatever node is being driven by that master node. In Shake, it's the opposite way, and dependencies are displayed and vice versa. So that's something to get used to, but that doesn't take long. Cool, so now that we've put our flare there, I'm just going to go to presets and hit the multi-penta, and you can see, yay, we get all those little bits and pieces here. And I'm going to scale it up to actually, whoa, whoa. I'm scared. Right, so of course, from now on in, you're probably going to spend at least 2 days tweaking this lens flare. But let's say we don't like the position all that much, and we actually want to go back and tweak it a little bit. So, in fact, we're going to cheat it down a bit. So I'm just going to jump back in here. And in the axis, I'll just push that further down into frame. Maybe I should do it interactively. Oh well. There. So push that further down. And this is sort of the area we're seeing in the comp over here. So we'll just push it just out of frame, something like this. Back to the Reconcile 3D, hit create keyframes again, hit go. Watch the whole thing update. There's our camera, there's the axis. You can watch everything move. Have a very quick coffee. Okay, that's probably a bit low. But hey, you get the point, right? So tweak it.
This is Nuke, there's no time for coffee.
Yeah. I've given up smoking since I started using it. Cool. So what does that look like in motion? Yes, see, I did tweak it a little bit.
Yeah, you tweaked it a
But
lot.
no, just a little. Okay, that's
You spent days tweaking
frame
that.
cycle. You said you wouldn't tell. Okay, so you can see that the lens flare sort of reacts to our 2D track, especially when we pan up into the sky now.
There you go.
And of course, there's those beautiful Tinder lens flares, for just a little bit of extra money. I'm not going to finish the sentence because I'm not getting anything for that.
Because I had Tinder on my machine, you wouldn't let me do it. I could have done it with the Tinder flare.
Yeah. See, he does want to tweak lens flares.
I do.
Gaia. Okay, cool. So there's one more thing I want to show you, which is pretty much the same sort of setup here. So for the sake of speed, I've pre-rendered what we have so far. And we'll do the same thing that we just did. Create a Reconcile 3D node, but this time we're going to use it to stabilize the whole image, because we do have this quite harsh handheld feel, and let's just sort of get rid of the high frequency noise in it. So we use the same technique, really, extracting 2D information from a 3D scene, because we've got it there, so we might as well use it. I've positioned that axis. This time I've put the axis sort of up at the upper right corner of the house, because that's what we're gonna be looking at. So it's sort of the center of interest, at least in the end of the shot. Anyway, plug that into the axis, and I just plug that straight into the image this time. And yeah, I'm gonna copy that again. And just to make sure that that's clear, you don't have to clone all those cameras. Of course, you could use one camera and just create a network and connect everything to that, and use my favorite nodes, the dot nodes. Great operator. You hit Control, and you can spend hours doing this. It's great. You can just do artwork like that. Anyway, you could create just one camera node, hook up all those nodes that require a camera to that, and you have sort of the same effect, but a million more pipes. So whichever way you prefer, it's all possible. Anyway, so back here we've done the same thing as we did before with the lens flare, so we'll just create keyframes. This time we're going to get the 2D tracking information for the corner of the house. And done. And I don't think I need this anymore, so I'm going to close that pane and focus on that single view now. So once again, we've got the 2D tracking information right here now, and I'm just going to use a standard tracker node to stabilize the shot. So I'll open that as, here's our Reconcile 3D 2, and I'm going to copy this animation curve into track 1. This time I'm holding Shift. There's multiple ways of doing this. You could just click the animation menu, go to Copy, say Copy Animation, and go over here and go to the Copy menu again and paste the whole thing. So this copied the thing. It didn't create an expression link. It copied the entire animation curve. A nicer way of doing it is just use Shift and drag the whole thing over, and that's the same thing. So Control or Command dragging will create an expression link. Shift dragging will copy the entire animation or expression. And you could also use Alt, which makes absolutely no sense in this case. And that will copy the current value only, leaving it as a static value. But we want the whole animation, so we're using Shift, and we're happy. The reason why I didn't expression link this, but rather create its own unique instance of the animation curve, is because I want to edit it a little. So I'll go into the curve editor here, and you see all those high frequency bumps. I'll just get rid of that by selecting all the curves, go into Edit Filter. We'll hit it 5 times because we can, and all the bumps are gone now. So now track 1 represents our smoothed curve, while the original output in Reconcile 3D holds the original curve. So now, one thing to remember is I don't really want to use the smooth curve for tracking or anything. So I'm going to deactivate this to make sure it doesn't have any influence for the transformational property of that node. So now it's just a container really that stores data. The Transform tab now holds the transform data in the tracker node that actually affects the image. So in the Translate tab, in Translate knob here, I'll go into Edit Expression and grab the original track from the Reconcile 3D2 .output node. Output there. So this syntax, I believe, expression linking is the same exact thing as in Shake. Node name dot field name, or knob name, or parameter name, or whatever you want to call it. So that's the same thing. This is our original jittery track, and we'll subtract the smooth version that lives in the knob called track 1. I don't have to precede this with a node name because it's living in the same node, so it's going to look for the name in the same node first. Now, again, notice again, I wasn't very verbose by actually typing output.x and track1.x. I skipped those things, making this a much more generic expression, and the fields in Nuke are clever enough to say, if this is referencing a multi-field knob, I'm going to look up X because I am an X knob, and the Y knob is going to look up the Y portion of it. So I can keep the same expression in both, which makes it actually a lot nicer to deal with expressions in two or 3 field knobs, or 10 field knobs if they're ever possible. And it makes sense. Makes sense. No, thanks. 4 fields, I think, is max. Okay, hit OK. And now let's have a look at this one in the curve editor real quick. You probably know what we're going to see, but I've got another 3 minutes, so I might as well waffle on. So this is now the jitter that we removed by the smoothing operation, the filtering operation of the original track. Let's have a look at the smooth curve, and there's the difference between the original track and the smooth one. And down here, oops, not that one. Where are we? Output, right? See, I'm tired now. I'll just select all and find it. There it is. Middle mouse drag, and you zoom it right in. So this is what the tracker is now using. So all we have left to do is hit stabilize, and we're now stabilizing the whole shot using the tracking information that we didn't really have to create from scratch anymore. Of course, I pre-rendered this. So looking at the output, we now have a much smoother result with a lens flare and sky and everything. Cool. So hopefully this showed that you can use the 3D system for a lot more simple or more common tasks in compositing than actually shading, projecting, lighting, doing UV unwrap stuff or something like that. But rather use simple CAD techniques or even the 3D, Reconcile 3D stuff to provide yourself with tracking information. Because once you've got a camera that matches the plate and geometry, 2D tracking is really completely redundant as long as you have good reference points in 3D, and it's going to save you a lot of time. So that's that. I guess we can jump right into QA.
Perfectly on time too.
Are we?
Yeah.
No, I've got one more minute.
Like a Swiss watch, man.